Hello again. Hope you had a nice Christmas. Mine was fairly good, so that's all that matters, isn't it? So, back to the testing. And today's victim is a Dressler 70cm preamplifier, which looks fairly old and weather beaten. Oh, the dehumidifier, hang on. Where was I before I was so rudely interrupted? Okay, I've already had the screws out of this, as you can see, because I wanted to see what was in it. But what it says on here is ultra low noise preamplifier. I don't know if you can read it. It's the model number, and it does say GAAS, which to those with the knowledge probably means it's got a gas FET in it. So a gas FET's well known to be very low noise. Now, you would use this normally if you're a serious DXer on 70cm, and you would have it connected up at your mast by your antenna. Usually would be used on single sideband. That's the only place to go really for DXing on 70cm. And normally you would power it up the coaxial cable, although I spotted that, and that I'm certain, well, I know it is the alternative way of powering it. But you can feed DC up the coax, that's the best way to do it. But there I encountered a problem. Put that to one side. I have these boxes, sequencer boxes, which would typically be used to plug into your radio and control various devices that you have connected in line, like a power amplifier and a preamplifier. And on the back, as you can see, it's got end sockets. So in theory, using this and connecting it to 12 volts, you would connect that to your radio or power amplifier, and that preamp connection, which is upside down, would feed via the coax up to the masthead amplifier, because putting the masthead amplifier right next to the antenna is the best way to overcome any losses in the cable. It would be far better than trying to use the amplifier by your radio. But here I encountered a problem. I can quickly show you. Where's my wires? My bloody wires. Now I know this is negative and this is positive, and now they're shorting out, of course, or not connecting at all, which is absolutely typical. So here we are. Here's a sequencer, and you can turn your power amplifier on and off with this, and in theory you can turn the preamp on and off, but it does nothing. It doesn't light up, it produces no voltage out the back. So I'm mystified by this. Also got two cables which would plug into your radio. One of them's PTT line, so I'm assuming that's a short, which would switch in from transmit to receive and switch out the preamp, and the other one is to go to your PA, which I'm not going to worry about that because I've got a PA, power amplifier. But there was no way I could possibly get this thing to light up that preamp light nor would it put out any voltage on the back here to feed the masthead preamp. Didn't make any difference what I did with these PTT line connectors, still didn't work. So I give up on this box. Don't know how it works. Not sure if you can get a manual for it, but I don't want to be bothered with all that at the moment. I just want to test the preamp. So, shall we test it, or shall we take it apart? So I've got a screw broken off. Yeah, it's got a screw broken off there. Well, at least it hasn't got a screw loose like I have. So let's take it apart. I'm guessing this is going to be from the early 80s. Certainly looking by the weather damage, it's been around for some time. And strangely, looks like somebody originally would have soldered the top and bottom on, but they're no longer soldered for some reason. And steel case is quite rusty, but inside it looks pretty good. And what have we got inside then? Well, you need to switch. As in normal mode, without power on the device, the signal will come straight in there, straight out there, with little attenuation, and then you put your power through it on transmit. So the coaxial relays would then be switched on receive to pass the signal through the preamplifier. So let's have a look at the preamplifier circuitry and get my light and everything right. So how does it work then? That's the antenna socket coming in. Switch through the relay and coming in here to a piston trimmer. So that makes sense. And goes through all the gubbins and comes out again to the next coaxial relay. So, as is typical with RF magic, we have a piece of silver plated wire which is shorted to the chassis of that and goes to a trimmer and then to another trimmer, so some sort of input tuned matching section, and there's a little black thing which will be the gas FET. No biasing on the input on the gate, so maybe they're biasing it in another way. I think they're biasing it by holding the source, which are these two. It's got two sources for low inductance, and they've got resistors down to earth. So the source is not a DC earth, but they've also got, what do you call them? Forgotten the name of them. Legless. Well, they are legless capacitors, which make the source very low impedance to earth. Chip capacitors, coffin capacitors, whatever you want to call them. And then that comes out through the little hole. Was it a bit, I think I might be zoomed in too much. Then we've got a bit more tuning with not such nice capacitors, film trimmer capacitors, Personally, I think they should have stuck to air-spaced, silver-plated ones. But whatever. I guess it still works okay. And a few more bits and pieces and nothing very interesting. Load of diodes. Not quite sure what they would be for. Static protection. Not sure. But anyway, that's what it looks like inside. And I know that these things were very expensive when they came out. I won't put it back in. I think it would be talking 100, 150, 200, maybe more for one of these, because it's a highly specialised bit of kit to make something like this. I have made preamplifiers for 2 meters using gas fats, but not as elaborate as this one. I did manage to find some data on it on the internet, not much, probably because it's getting on in age now, and it did say the gain is roughly 14 to 16 dB of the preamplifier, which is what you'd expect. You don't want too much gain, as you may overload your front end on your radio, and you've got to have enough gain to overcome cable losses with a bit more on top. What it also said was you could put 150 watts continuously on transmit through the device when the preamp's off, in FM mode, so not that I would use it in FM mode, and that would be about right for these relays. That's about their top rating. They do bigger ones than these with N-type sockets on, but in SSB mode they rate it at 500 watts. It may be okay at 500 watts, but it's a little bit high. It's not a continuous signal though, SSB, so it probably would be okay. So now what we need to do is try and test the thing. So it's back on the good old spectrum analyzer. Now I've got 2 fairly long cables, but I'm not worried about that. And if I connect them together, RG58, which is not to be used for too long lengths at UHF, but I've already normalised this earlier, so joining those two together, now I have normalised it, but I'll do it again just for something to do. Normalise on reference line at 432. That would be typical frequency to use it on, 432. That's the sort of centre of the single sideband, not 431. Centre of single sideband on, let's put 432.2. That's the sort of calling channel on 70 centimeters SSB. So now what we can do, we can connect this thing in series, making sure I get it the right way around. Signal from tracking generator goes into the antenna port. Output from the tracking from the preamp goes into the input of the spectrum analyzer. As it says, receiver. The spectrum analyzer is a receiver in my case. So now what have we got? We got a baseline measurement of the loss of the system when it would be used in bypass mode with no preamp in use. I'm already seeing quite a high attenuation. I think that's high, 0.6 dB. Whether it was always that high or whether it's suffered with corrosion over the years, I don't know. The relay contacts may need a bit of a clean, who knows. But to me, I would like to see it lower than that. If you were, say, putting out 100 watts in this mode through it, you might get about, let me try and think about this, you might lose a 5 watts through it with 0.6 dB attenuation. But fair enough. Now what I'm going to do, I'm going to get my cables, connect one to the earth of the unit and the other one to the feed-through capacitor, and there we have the response. And if anything, I'd say it needs a tweak, because we've got a bit more going down there than is usable. You know, it's not the greatest, and dodgy connections. I mean, I could try tweaking. Where has it gone? These things, these pistons. See what they do. I don't want to do too much tweaking. I don't know whether the owner approves of me tweaking it, but I'm going to leave it like that. But of course we've got other things we can tweak on the other side. These film capacitors, let's have a tweak of them, see what we can do. At least I do know what I'm doing. Oh yeah, you can change that quite considerably. And I can center it on 432 when I can get my tool in. Yeah, that's okay. I'm going to leave it like that. That's pretty good. So, as I said, 14 to 16 dB. Well, that's near enough 15 or 14 and a half. And it's got quite a wide bandwidth. I mean, it's got to 450. Still 11 dB at 450. Could use it up there quite happily. And you could use it all the way across the UK, 70 centimetre band without any problems at all. I mean, it does drop down considerably, which is what you expect. Okay, 0 at 400, 0 dB gain at 400. That's about what you want. And just for fun, let's do another experiment. So what I've done now is I've widened my span, and starting at 182 and that end, and stop frequency is 680 for some reason. So now we've got a nice typical curve, and we can take it down. See, you get down here now and it's got minus 30 dBs of gain at 300, and let's try 500. Zero at 480, and 600 minus 35 dB of gain. So there you go, that's all you can say really. Back to the megahertz. That's it, back to there again. I suppose if you're really desperate and stupid enough, you could tweak this to work on TV bands. Bit of a waste though, but it is what it is, I guess. But I think before I would use this in anger, I would be taking out the current. So I realise actually the tops come off, I know that, so you can get in there and clean them. They may need cleaning, they may not, or it may just be the way it's always been. But interesting little device. Wish it was 2 meters. That would be far more useful, and I'd quite like that, have that here on my Yagi. Never mind, can't have everything. Bye for now.